Hi friends, welcome to GMK tutorials. In this video we are going to see one of the most important topic is Laplace transform. It is used in different applications like electrical circuit analysis, as well as if you go for any signal processing applications and all those things. It plays a very key role, okay, to identify the corresponding signal properties as well as convergence of the signals, as well as if you want to find out the gain of the gain or transfer function of the systems and all those things. So let us see the one by one. So generally, Laplace transform is a powerful tool. It can be represented as a L of S like this, S domain. It is also used as a S domain. Okay, Fourier transform is represented as omega. Okay, it can be represented S domain. Fourier transform is one of the special case. If you don't have any basics in the Laplace transform, please go and watch our Laplace transform videos on the our tutorial also in signals and systems concepts also. Okay, so let us see for Laplace transform is the general formula for this one is equal to just I will write integral minus infinity to infinity x of t into e power minus st dt. This is the Laplace transform formula. Now suppose if you are taking any system, it consisting of an input x of t, output y of t. If you want to find out the response, or if you want to find out the transfer function of the system, output by input is generally gain, right? We can call as a transfer function in the S domain, right? Suppose if you want to find out this one, first of all we have to apply the Laplace transform. Okay, let us see here. Laplace transform of x of t is gives rise to x of s. Laplace transform of output, that is nothing but y of t, which gives rise to y of s. Now transfer function is defined as it is a ratio of output response y of s to the input excitation x of s. Okay, it is a ratio of transfer function is equal to, it is a ratio of output response y of s by input excitation x of s. So transfer function can be represented as h of s, that is equal to y of s by x of s. Okay, so before going to so let us see some of the examples related to the transfer function. Just we will see some basic Laplace transform functions that are used in the analysis point of view. Just I will note down this one. Just mention this one. Laplace transform of del of t is equal to 1. Okay, this is like if you are taking the Laplace transform is equal to integral minus infinity to infinity x of t into e power minus st dt. So here x of t is equal to del of t. Del of t is exist at t is equal to 0. Therefore, if you are substituting t is equal in the 0, therefore this value is equal to 1. As well as Laplace transform of u of t is equal to 1 by s. Laplace transform of e power minus at into u of t is equal to, generally Laplace sum of u of t is equal to 1 by s. So it is nothing but a multiplication factor. Multiplication in time domain is equal to shifting in frequency domain. Therefore, s plus a. Okay, as well as Laplace transform of t is equal to 1 by s square. It is a ramp function. It is also ramp or step function. Sorry, it's a ramp function only, not a step. As well as Laplace transform of t power n is equal to n factorial by s power n plus 1, as well as Laplace transform of t into e power minus at is equal to, generally e power minus at is equal to 1 by s plus a, right? Then t is nothing but it gives a square, right? t square. Then Laplace transform of sine omega t. This value is gives rise to omega by s square plus omega, as well as Laplace transform of cos omega t is equal to s by s square plus omega square, as well as some more properties. Laplace transform of e power minus at into sine omega t is equal to omega by s plus a whole square plus omega square, as well as Laplace transform of e power minus at into cos omega t, which gives rise to, generally cos is nothing but s, so shifting is equal to s plus a by s plus a whole square plus omega square. So these are the some of the important formulas which are related to the Laplace transform. So let us see some of the examples related to Laplace transform. Find the Laplace transform of find the Laplace transform of f of t is equal to del of t plus 2 into u of t minus 3 into e power minus 2t, sorry, into u of t. So you have all the formulas. So just apply Laplace transform to the above equation. The Laplace transform of f of t is equal to f of s. Laplace transform of del of t is equal to 1, and plus 2 into Laplace transform of u of t is equal to 1 by s minus Laplace transform of e power minus 2t into u of t. U of t is equal to 1 by s. E power multiplication is equal to 1 by s plus 2, s plus s plus 2. So this is a formula for finding the Laplace transform of the corresponding function. Suppose if you want to find out the Laplace transform of, so let us see, find the Laplace transform. One more problem, let us see that very quick. Find Laplace transform of f of t is equal to cos 2t plus e power minus 4t u of t. Here also just I will multiply u of t cos 2t into u of t plus. Now apply the Laplace transform to the above equation. Apply Laplace transform above equation. What we are getting? F of s is equal to Laplace transform of 2t into u of t. It is in the form of a cos omega t format, right? Cos omega t format. Cos omega t is equal to what we are getting here? S by s square plus 2 square, that is nothing but 4, as well as plus, what is the value of this one? 1 by u of t is equal to 1 by s, but shifting in frequency domain is equal to multiplication is e power minus t, therefore you will get s plus 4, right? Therefore if you are taking as a LCM for this one, LCM for this one, we will get some answer, it will be there, right? So depending upon the situation, in case if you want to need a LCM for this one, just if you are substituting all this, we will get around, that is equal to 2s square plus 4s plus 4 by s plus 4 into s square plus 4. This is the answer for this one, right? Now our interest is just to have to find out the transfer function, right? Transfer function. So let us see, I will consider one example for this one. Find the transfer function. Find the transfer function. Find the transfer function of LTI system. LTI system. Response y of t is equal to, what is the value? 10 into e power minus t into cos 4t into u of t. Cos 4t into u of t. When the input x of t, where x of t is equal to, input x of t is equal to e power minus t into u of t. Okay, find the transfer function. No, right? If you want to find the transfer function, we have to find, so transfer function h of s is equal to y of s by x of y. So from the given data, given that x of t is equal to e power t into u of t, therefore x of s is equal to Laplace transform of x of t is equal to, now apply Laplace transform to above equation. What we are getting, x of s is equal to 1 by s plus 1, right? Then at the same time y of t is equal to 10 into e power minus t into cos 4t into u of t, right? So if you want to find out this one, we can directly write, I will here just apply Laplace transform to above equation, right? Then it can be represented as y of s is equal to 10 is a multiplication factor, no problem. Okay, actually u of t is equal to, for defining a cos omega t, right? So here generally cos is nothing but, just I will write down this one, s by s plus 4 square, right? But the problem is that e power minus t will be there. So multiplication in time domain is equal to results in shifting in frequency domain. Therefore, s plus 1 will be coming here, as well as s plus 1 whole square will be here, right? So that is the equation. Now if you know the y of s and x of s, definitely you can calculate the h of s value. Therefore, h of s transfer function, h of s is equal to y of s by x of s. So therefore from this equation y of s is equal to 10 into s plus 1 by s plus 1 whole square plus 16 by 1 by s plus 1. Okay, 1 by x of s is equal 1 by s plus 1. This will give rise to 10 into s plus 1, again this s plus 1 by s plus 1 whole square plus 16. So that gives rise to 10 into s plus 1 whole square by s plus 1 whole square plus 16. This is a transfer function for Laplace transform, right? If you want to find out the transfer function for the transfer function to the equation, we can calculate it like this, right? I hope this video is very clear for you, I think, right? Suppose so, this is a way we are going to find out the Laplace transform to the equation, right? So if you want to find out the h of t impulse, just apply the inverse Laplace transform to this one. This is the way to process. As well as one more practice problem will be there. Let us see here. This one is equal find the transfer function. Find the transfer function of given data h of is h of is a I mean they will give the actually y of t input and impulse response are expecting, right? So let us see. Sorry for this one. Just a small question will be changed like this. The given that a transfer function is equal to h of s, they are given already. H of s is equal to 2s by s plus 6. They are giving like this. Okay. Then what they are expecting is find the y of t. Okay. They are not given any x of. They are not giving y t. Find y of t. The input x of t is given as input function. They already given input x of t is equal to 45 into e power minus 3t u of t, right? So this is a problem actually. Now we have to find out the solution for this one. Solution. Okay, let us see the solution. So from the given that h of s is equal to 2s by s plus 6. H of s is equal, what is the value? Y of s by x of s is equal to 2s by s plus 6. What we have to find out here? Y of s value, right? We have to find out the y of s value. Therefore, from this equation, y of s is equal to 2s by s plus 6, right, into x of s. Now you have to find out the x of s value. What is the value of x of s here? So from the given data I will represent here x of s is equal to 45 into e power minus 3t into u of t. Now apply Laplace transform. What we are getting here? Apply Laplace transform. This is nothing but x of t, right? Not x of s, x of t, right? Then this value is equal to x of s is equal to 45 is a constant, no variations in this one. 45 is as usual. E power minus 3t into u of t, right? U of t is equal 1 by s. It is a multiplication time domain. So according to the formula of Laplace transform of e power minus 8 into 1 by s plus a, therefore this value is equal to s plus 3. S plus 3. Now y of s is equal to, from this diagram, y of s is equal to 2s by s plus 6. X of s value is equal to 45 by s plus 3. Now we can represent y of s is equal to 2 into 45, 90s by, okay, 90s by s plus 3 into s plus 6. If you want to find out the partial fractions for this one, y of s is equal to like a by s plus 3 plus b by s plus 6. Now if you want to find out the a is equal to s minus a value, that's nothing but s plus 3 into total value of 90s by s plus 3 into s plus 6 at s is equal to minus 3. S minus 3, s minus 3 get cancelled. If you are substituting s is equal to minus 3, what we are getting? 90 is equal to minus 3. Sorry, s is equal to minus 3 means that we will get subtract this one by um, minus 3 plus 6. This value is gives rise to 3 only, right? 3 get cancelled. Now we will get minus 90. Therefore, a value is equal to minus 90. Then we have to calculate it b value also. Now we have to calculate it b. B is equal to s plus 6 into, this is a shortcut method, 90 into s by s plus 3 s plus 6 at s is equal to minus 6. S minus s plus 6, these two get cancelled. S is equal to minus 6, right? 90 into minus 6 by s is equal to minus 6 plus 3. This value is equal to 90 into minus 6 by minus 3. We are getting minus 3 actually. This minus get cancelled. 3 ones are 3 twos are. Therefore 92s are 90 into 2. We will get 180. So we are getting a value and b value. Therefore y of s is equal to a is equal to minus 90, right? A is equal to minus 90. 90 by s plus 3 as well as b is equal to 180 by s plus 6. Now if you are applying the, if you want to find out the y of s value, y of s, it is actually we are requiring, our need is just we have to calculate the inverse Laplace transform. Therefore we will get y of t is equal to minus 90 into s plus 3 is equal to, it is in the form of e power minus 80 into u of t is equal to 1 by s plus a. Now if you are reversing this one, what we are getting here, e power a value is equal to minus 3t, okay, plus 180. S plus 6 means that e power minus 60, minus 60. This is the equation for output equation for the given transfer function when we give h of s function and input values, right? This is the given data from this one. Right, so this is the way we are going to calculate the corresponding given data. That means if they are giving a transfer function and input x of t, then if you want to find out the output response y of t, just you have to take the h of s transfer function. You can represent x of y of s by x of s format. Just to take y of s in the left side, then you will get all terms in the right hand side. Then you have to calculate x of s function from the given that. Then you have to substitute, and using the partial fractions y of t, we can get like this also. This is a response, right? In case if you want to, if you want to find out the impulse response for the given h of s means, just you have to calculate the inverse Laplace transform to the h of s function. We can get the impulse response, right? So this is the way we are going to calculate the transfer functions of the Laplace transforms.